In this video, we will discuss about the big theta, the third asymptotic notation. In my two earlier videos, I have discussed about the big O notation and big omega notation. And now we will discuss about the big theta notation. So, in order to understand big theta notation, it is very essential to go through with the big omega and big O notation. So, if you have not studied that, please refer to the previous videos, and then it is better you will refer this video. So big theta notation, first of all, we'll go by the book's definition, text definition. It says, again, there are two functions, fn and gn. It says fn is said to be theta of g of n if and only if we have some constant c1 and c2 and not greater than 0, such that f of n is less than equal to c1 of g of n greater than equal to c2 of g of n. Now this definition, obviously, for every n greater than equal to n naught. This definition seems to be little bit tricky or little bit difficult, but let's try to understand what big theta is. So again, we'll plot one graph. There is some f of n and there is some g of n, c1 into gn, c2 gn, and you can see gn is same and there is a difference of only the constant. So this fn is tightly bound between these two limits, c1 into gn, c2 into gn. Okay, so if it is so, if we are able to find out some lower bound and some upper bound for a function fn, given function fn, if we are able to enclose that, tightly bound that, in that case we can say my fn is equals to theta of g of n. The task is to identify this g of n with some varying constants which are greater than 0. Okay, so let's try to understand this with some example. So say my f of n is 3n plus 5. Now this 3n plus 5, I can rewrite it as, in the terms of, I can take the gn as say 8n and say 2n. I can take it as 1n, no problem. I can take it as 3n even, then there is no problem. So now you can see g of n, this n is g of n and this 8 is c into g of n. Here this is c1, this is c2 into g of n. Try to understand it, because maximum students does kind of mistake in this level. Remember, this n has to be same, because gn has to be same as per definition. There is no change in gn. There will be change only in c1 and c2. So in this case my c1 is 8 and this case my c2 is 8. Obviously n is greater than equal to 1. Okay, so if it is so, now we can see my fn is less than equal to c1 into gn. Here c1 is means 8 into n. My fn is greater than equal to c2 into gn, 2 into n. My definition is satisfied. If it is so, I can write my Fn equals to theta of n. Okay, so I have I am able to find such a Gn with varying C1 and C2 where my Fn being enclosed between two extremities, two limits. So that's why this theta, big theta is also known as tight bound. Big O was the upper bound, big omega was the lower bound, big theta was the tight bound. So hope it is clear to all. Thank you. Thank you for watching this video.